We are going to look at planes in three-dimensional space, how to use vectors to find equation of planes. A vector perpendicular to a given plane is denoted by n, and we call this the normal vector to the plane. On a diagram, it looks like this. On a diagram, if you have a normal vector to the plane, then you'll find that if you draw any vector on the plane, you'll find it will be 90 degrees. No matter how you draw, the vector on the plane need not be at right angle to each other, but you will find that no matter how you draw your line, the normal vector is always at right angle to the line. So when you have a normal vector to a plane, you will find that no matter how you draw your line, the normal vector will be at right angle to the line on the plane. So you'll find that the normal vector is always at right angle to all the lines which you can draw on the plane. So let's fix a point A on the plane. So let's fix a point A on the plane. So A is on the plane. And let P be any point on the plane. So we have another point P on the plane. And let the position vector of A and P be small a and small r. Then vector AP is perpendicular to the normal vector. So we can immediately connect A and P. And if you draw the normal line, so you'll find it be a right angle. Right? And if you write down AP is just OP minus OA, so it's just R minus A. Then because AP is a vector on the plane, AP dot n must be 0. So AP is just R minus A. So R minus A dot n will be 0. Then if you expand out, it will be R dot n minus A dot n equal to 0. So it's same as R dot n equal to A dot n. And this is the vector equation of a plane. N is a non-vector. So n, let's say n is equal to AI plus BJ plus CK. And A is a vector, so we let it be the vector with x component, x1, I, y component, y1, j, then z component, z1, k. Then you'll find that you can work out A dot n. Then A dot n will be just ABC dot with x1, y1, z1. Then it will give you AX1 plus BY1 plus CZ1. And this will just give you a number because A is a point on the plane. It is a fixed point on the plane. So the component x1, y1, z1 are just some fixed number. Then the normal vector A, B, C is the component of I, J, K. So A, B, C will be some fixed number. So that means this add up will give you a constant, we can call it D. So that means the equation of a plane, right, can be written as R dot n equal to D. And D is a number. D is just a number, a constant. Later we shall see more examples, and you understand better. That's the reason why if you look at slide 68, you will find that you are asked to find equation of the plane in the form R dot n equal to D. So this D is what I just mentioned. Because A is actually A dot n, and A is just a fixed point on the plane. So A dot n gives you a constant D. So that's the reason why in set 68 you are asked to find equation of plane of this form, R dot n equal to D.